Jai Hind everyone. I Neeraj Sharma, Assistant Professor in EC Department at Akgec Engineering College, Ghaziabad. Before you to present the complex video lecture series for the subject Microwave and Radar Engineering, whose code as per the AQTU scheme, that is the KEC 074. So, for this lecture I have chosen the topic H-plane T junction, which is dedicated from the unit 2 of this subject Microwave and Radar Engineering. So, in this lecture, this is the H-plane T junction. It comes under the category of microwave component. So, for that we just gone through with this when the three ports are matching or at the main waveguide, if we are connecting one another waveguide, so it will becomes a junction. So, it is simply named as a T junction. So, if main waveguide having the two ports, like simply let us say it will be a waveguide, this is port 1, this is port 2, and when we are connecting one another port like this, here this combination, so this will become the T junction, but here the port becomes the 3. So, these microwave component, when the 3 port junctions will be there, so they have the 3 port junctions having the examples of E plane T junction, H plane T junction. So, what we did, if we are just simply if we are, let us say this will be a main waveguide, primary waveguide, port 1 and port 2, if we are connecting the port 3 here in this direction, like this one if we are attaching, so this combination will become H plane T junction. If we are connecting the waveguide, auxiliary waveguide along with this primary waveguide like this, so this type of combination will become the E plane T junction. So, these two junctions having the property of either they can split the power equally when we are feeding the power at port 3 of auxiliary waveguide, and it will simultaneously split towards the port 1 and port 2 in phase in H plane. If out of phase, it is splitting port 1 and port 2, it is a E plane junction. If we are so this is simply in a power dividing circuit, behaves as a power dividing circuit. If we can just apply the input simultaneously from port 1 and port 2, so the additive power we can get at the port 3. So, that means we can also use these junctions as a power combiner. So, these two junction E plane, H plane having the 3 ports, if we have combination, make the combination of this E plane or H plane simultaneously, so this the number of ports will become 4. So, this will become comes under the category of 4 port junction, whose examples are the hybrid T, that means this will be the combination of E and H plane T junction. Next one, that is the hybrid ring junction, directional coupler, hybrid coupler. Okay, so these are the also microwave component. Another component based upon to this ferrite devices, these are some high resistive materials, which works ferrite oxide based materials which having the 2 ports, that is their examples are isolator and circulator. Isolator is a 2 port device and circulator may be n port device. Okay, similarly, another waveguide components we discuss, that is the attenuator, phase shifter, wave coupling, bands and twist. Okay, waveguide discontinuities, iris and tuning screws. And for the measurement point of view, component we are using here, that is the mesh load, detector, tunable, detector, slotted line, etc. So, these are the some microwave component. So, out of these, now I have chosen the topic T junction. So, that means we are connecting the main waveguide is connecting some or the auxiliary waveguide, then become the T junction. So, the T junction are the power divider at 3 port power dividing or combiner, that means the that is the used to split the power. Okay, so either we can here the power we can combine here or we can split here. So, these are simply of 2 categories. The first one, that is the E plane T junction and H plane T junction. So, in the continuation, so just I have chosen the topic. My topic is that is the H plane T junction. So in this H plane T junction, we are now primary waveguide, at the side arm we are connected the another waveguide. So the three ports will becomes there, and it is simply named as an H plane T junction. So H plane T junction has this side arm parallel to the H field of the main waveguide. Okay, that means the magnetic field. When used as a power divider, that means this one. So the electric field at port 3 will be divided with equal phase in port 1 and port 2. That means when we are entering the power from port 3, it will equally split along the port 1 or 2. Alternatively, when applied as a power combiner, that means when we fed the power at port 1 and port 2, it will be combined at port 3. So if port 3 is symmetric, generally we have to consider the symmetry of the structure. So if port 3 is symmetric, then the amplitude of the electric field divided between the port 1 and port 2 from port 3 and meshed as an H plane. So this T junction can also be used as a 3 dB power divider circuit. So if we can apply the power at port 1 and port 2 of same amplitude, but in opposite phase, then another important thing that we are applying the power port 1 and port 2 same, but condition is that amplitude same but out of phase, then the output power at port 3 will be 0 due to the phase cancellation. That means nothing will be we can get at the port 3, but if it is same amplitude and same phase, then we can get the power at the additive nature. So this is simply an H plane T junction. So in the H plane T junction, that is the hardware of this H plane. This will consider as a main waveguide. Main or primary waveguide. So this one part, and this is your auxiliary waveguide that we are connecting here. So is geometrical, we can see that this is the main waveguide or the collinear arms, that is the port 1 or port 2 here. This one first port, this is second port, and at the side arm we are connecting this one port 3, means auxiliary waveguide we are connecting here, that is your port number 3. So this will be the hardware model of this H plane T junction, and that is its geometrical representation we can see here. So when we can apply the power here, we can apply the power, let's say this mode we can now transmitting or applying as an input from this port 3. So what will happen in this? It will have a geometry, symmetrical geometry. So the power will be distributed like this one, and this can be appear here like this. So that means the same power which can be applied from port 3, that can be equally split into port 1 and port 2 here. So this is this is a geometrical structure. So the H plane T junction is formed in the basic definition by attaching a simple waveguide to the narrow dimension of the rectangular waveguide, which already has 2 ports. This means port 1, that is port 2. So this another we can add here as a port 3 here. So the arm of the rectangular waveguide makes 2 ports called collinear ports, means this one. These are the collinear ports, and that means port 1 and port 2, while the new one port that we are attaching, that means this is the main waveguide we are connecting like this. So this will be your new port 3 is called the side arm or H arm. Also this can be named as a shunt T junction, okay, as well as the axis. Why it is called this one shunt T? As the axis of the side arm is parallel to the magnetic field. So the junction is called the H plane T junction. So this is also called as the shunt junction, as the magnetic field divided into arms. Here the distribution of the magnetic field equally from port 3 to port 1 or 2 here. Now after that, some another properties of H plane we can think here, that is the case 1 we can consider here. When T10 mode is made to propagate into port 3, the wave will split equally into port 1 and 2 in phase, and the same magnitude. As the wave propagate through the side, there is no wave bending. That means the wave here at this point, the wave is not bending here. So that means like enter here, so it will be can equally split, not like this one tilting possible here. So another thing, the case 2, when the electric field waves enter from the two collier arms having the same polarity, the wave that comes out from port 3 is additive. That means that is the power combining here. Or if opposite phase, then equal to cancel the power we are applying from this port 1 and 2 here with same amplitude but opposite phase, then that means the output at port 3 we will get it is 0 here. So these are the some two properties for the H plane T junction. Now after that, this is the basic theory regarding this H plane T. Now for just to calculate or to measure its characteristics, so how can we measure it? So for that point of view, we can go for the is derivation. So the basic tool for the calculating of these properties for port 1 to the characteristic, what are the characteristic of port 1 when we are applying input 1, what action will get at the 2 or 3 port. If we are applying 3, what will happen at port 1 and 2 as well, if simultaneously. In the same way, if we are applying input at port 2, then what we can get at port 1 or port 3. So for that point of view, we can at the applied input at respective port, at remaining 2 ports, what the output we are getting. So for to calculate these value, we can use the S matrix model. So S matrix approach we can now go through for this 3 port device, that is the H plane T junction. So this can be calculated with the help of S matrix. So for that point of view, just to measure the value of this scattering parameter, we are using the S matrix. So first of all, for that calculation we are use the properties of S matrix. So in this the S matrix, if we can say, so that is given by, because it's a 3 port device, so the S matrix is always a square matrix. So the S matrix is of 3 cross 3 order, that is S11, 12, 13, S21, S22, S23, S31, S32, S33. So this will be the simple S matrix for the H plane T junction. Also, if we can say that just our task is to calculate the values of these 9 scattering parameters, was S11, S12, S13. That means if we are inputting giving the power at port 1, what is the output at port 1 itself? When input at port 1, output at port 2, input at 1, output at port 3. So in this way we can now characterize it. So just now we have to calculate its value. So as per the property, we can say that when the power, since the port 1 and 2 are in phase, port 1 and 2 are in phase with respect to port 3. So the scattering parameter S13 is equals to S23 here. So this one property we can now use here. Also the next point that we have to consider here, the if port 3 is perfectly meshed, that means at the main waveguide we are connecting the another port that is perfectly meshed. So that means if we are input given any power here, there should be no reflection at the same point. So that means reflection coefficient S33 is equals to what? 0 here. We can get in this case. So these are the two properties of H plane. Next now then we can use the properties of S matrix. So in this reference, so for symmetry property, that means what? Sij is equals to Sji. That means what? S12 is equals to S21. Okay. After that, S13 is equals to S31 and S23 is equals to S32. So we can now applying all these into this above matrix S. So the S matrix, if we can it can be reduced or simplified as S is equals to S11, S12, S13. Okay, then here S12, S22, S13, this is S13, this is S13 or 0. So this matrix will now reduce in this way. So this matrix is now converted to this one after combining all these properties of including its H plane matrix properties, H plane property as well as the S matrix property. So after that now we can now, assuming that lossless network and the unitary property of S matrix that means S into S conjugate is equals to I. So we can now simply S11, 12, 13, 21, 22, 23, 31, oh sorry, this we can apply onto this one S11, 12 to this one S12, S22, S2 So now we can get this. So now we can just perform the R1, C1, R2, C2, R3, C3 operations for this calculation point of view. So now we can get here some another equations. Mod of S11 square This one we can get. Okay, so these three equations we can get. Also we can get here R3C1 S13 S11 conjugate plus S13 S12 conjugate is equals to 0. So now our task is this, to just after with the help of equation 3 we can now we can, that is S22. So after that, so after solving these four equations we can get the values of this matrix S11 12 13 12 22 13 S13 S13 0 here. So we can now calculate all these. Now calculate the above four equations. From equation 3 we can get S13 is equals to 1 by root 2. From this one we can get that S1 is equals to minus of S22. So put all these values in equation 1. So we can get the value of S11 is equals to of 1 by 2 here. So now the final value of this S matrix for H plane T junction, that is 1 by 2 minus of 1 by 2 1 by root 2 minus 1 by 2 1 by 2 1 by root 2 1 by root 2 1 by root 2 or 0 here. So this will be the S matrix for the H plane T junction, and in the form of B is equals to S into A we can also apply this one. So here B is the reflected wave and A is your incident wave and B is your reflected wave. So in this we can calculate the output B1, B2, B3 in this way: 1 by 2 minus 1 by 2 1 by root 2 minus 1 by 2 1 by 2 1 by root 2 1 by root 2 1 by root 2 0 or A1 A2 A3. In this way we can calculate the output reflected wave with reference to the input incident wave here. Now after that, so this will be the calculation of this H parameter H plane T junction with the help of this S matrix. So some numerical problems can be asked into the exam. So just as I have just taken another example for the numerical point of view, that is the question is that a signal of power 32 milliwatt is fed into port 1. That means value of A1 is equals to what? 32 milliwatt of a lossless H plane T junction. Determine the power in the remaining ports. That means we are giving the input here 32 milliwatt. So what will be the power at this port B2 or B1? We have to calculate with reference to the input of 32 milliwatt. So for that point of view we can use this approach. In this B is equals to S into A here. We can now apply this one. So for that point of view, what we can do, B1, B2, B3 that is 1 by 2 minus 1 by 2 1 by root 2 . and A1, A2, A3. So the value of this A1 is 32 milliwatt and rest of A2, A3 what? 0. So this is 32 milliwatt, we can 0, 0. So we can now solve these equations here. So the value of this B1 is equals to A1 by 2, B2 is equals to A2 by 2. Okay, sorry, A1 and B3 is equals to A3 by root 2. So the power we can calculate here 1 by 2 square into A1. Okay, 1 by 2 square of A1, that means 1 by 4 into 32, that means 8 milliwatt. In the same way here 1 by 2 square A1, that is we can get 8 milliwatt. Here we can 1 by root 2 square A1, that means 16 milliwatt. So we can power at input port 3 16 when it is applied. So the same equal power can be distributed port 1 and 2, that means 8 or 8 here. If we can apply the same power at port 1 and 2, that means 8 milliwatt and 8 milliwatt, we can get the added power at port 3. So that means 8 plus 8, 16. So that means in this way we can solve the problem related to the H plane T junction. So this is now regarding for the H plane T junction. Thank you and Jai Hind.